Ever stop and think about what happens before a single line of code gets written for your favorite app or game? It's not magic, not at all. It's all about having a solid plan. Today, we are going to dive into the essential blueprinting that turns a simple idea into a program that actually works. Let's jump right in.
When you get right down to it, that's the real question, isn't it? See, programming isn't just about hammering out commands. It's about giving a computer a perfect, step-by-step recipe to follow. And to do that, you first need an absolutely crystal clear plan for yourself.
So this is pretty much the standard path for solving any problem with a computer. You figure out what you're trying to do, you make a plan, and only then do you start coding. For this explainer, we're really going to focus in on those crucial planning stages that make all the difference: the algorithm and the flowchart.
Okay, so where do we even begin? Well, we start with the most fundamental tool there is, the algorithm. Just think of it as getting your idea down on paper in plain, simple English.
That's really it. An algorithm is just a recipe. It's a list of precise instructions written in everyday language to solve one specific problem. No technical jargon, no code, just a clear, logical sequence that literally anyone can pick up and understand.
To really see how these planning tools work in action, we're going to stick with one super simple problem from start to finish. How do you figure out if a number is even or odd? It's the perfect, bite-sized example to show off each stage of the plan.
And check it out, here's the algorithm for our problem. See how straightforward it is? We start, we grab a number, and then we do one key calculation. We find the remainder when we divide that number by 2. This idea is the core of our logic, and it's something called a modulo operation. Based on that one result, we make our decision. Every single step is perfectly clear. This is our plain English plan.
All right, we've got our simple recipe. Now, let's level it up a bit. We're going to add a little more structure to our plan and create something that starts to look, well, a little more like actual code.
And this is where something called pseudocode comes into play. The name literally means fake code, and that's a great way to think about it. It's this perfect middle step that mixes the simplicity of our English algorithm with the structure of a programming language, but you don't have to worry about any of the strict rules or syntax.
This comparison here shows that evolution perfectly. Look at the left. The algorithm describes the action, find the sum. But on the right, the pseudocode makes it more direct, more operational. C equals A plus B. It's the exact same logic, just one step closer to what real code looks like.
So let's bring this back to our even or odd example. The pseudocode starts using keywords like if, then, and else to build that clear decision-making structure. And see how our plain English step, find the remainder, becomes the much more direct R equals N mod 2? That's that modulo operation we talked about, now in a structured format. It's basically a code-like instruction, but it's still super readable.
So why even bother with this step? Because it lets you focus purely on the logic of your solution without getting tangled up in commas and semicolons. It helps you catch flaws in your thinking early on before you've written any real code. And because it's totally language independent, this one plan can be easily translated into Python or Java or C++, whatever you need.
Okay, so we've written our plan in plain English, and then we gave it some structure. Now, for the final and maybe the most powerful planning stage, let's turn that plan into a visual roadmap.
A flowchart is basically the architect's blueprint for your program. It's a diagram that uses standard shapes and arrows to visually map out the entire process, from the very beginning to the very end. It makes the flow of logic and every single decision point instantly obvious.
Every flowchart tells a story using a simple visual language. Those flattened ovals, they're your start and end points. The parallelograms handle any data coming in or going out. Rectangles are where the work gets done, the calculations. And the most important one, the diamond, that's where the program has to make a choice.
And boom, this right here is our even or odd logic in picture form. You can literally just follow the arrows. We start at the top, we input a number n, we process it by finding the remainder, and then we hit that critical decision point. So yeah, that diamond is the heart of the whole operation. It's where the program thinks. It asks a simple question: is the remainder 0? If the answer is yes, we follow the true path. If the answer is no, we follow the false path. Each path leads to a different result, perfectly mapping out the logic we planned from the start.
So we've gone on a journey, right? From a simple idea in English to a structured recipe and finally to a detailed visual blueprint. Why does all this planning matter so much?
Because a great plan is everything. It takes huge, overwhelming problems and breaks them into small, manageable pieces. It forces you to clarify your thinking, and it acts as the ultimate guide when you finally sit down to write code. It really is the bridge that connects the problem you have with the solution you want.
And that's our look at the art of the plan. But here's a final thought for you. This way of thinking isn't just for coding. I mean, from making your morning coffee to deciding what to watch tonight, our lives are filled with little algorithms and decisions. So what's a simple daily task that you could map out with your own flowchart? Give it a try. You might be surprised what you find.